Alrighty, in today's video, we're going to look at 14.3, which is least common multiples of polynomials. All right, so in the very first question we're going to have is we're going to be asked to find a least common multiple of 10, 25, and 40. So here's how I like to do this, and this is the best way I've found for students, is we're going to start off with 10, 25, and 40. This is what 1 times all of this would be. So I'm going to try 2 times all this, and the goal is to get to the same number. 2 times 10 is 20. 40 is the largest number, so I want to keep going. 3 times 10 is 3 times 10 is 30. And then I'm going to try 4. 4 times 10 is 40. So I now got the 40. So now I'm going to try 25. So 2 times 25 is 50. But that didn't work. So now I got to get this one to 50. So 5 times 10 would give me 50. So now these are good. So now I got to try this one. 2 times 40 is 80. Well, that didn't work for me. So then I would have to now turn this one into 40. So this would be 6 would be 60, 7 would be 70, 8 would be 80. So then I go, all right, well, 3 times 25 is actually 75. 4 times 20. 4 times 25, that would give me 100. So then I gotta get this one now to 100. So this would be 90. And then 10 times 10 is 100. And then I would come over here. 3 times 4 is 120. So then I gotta go, all right, well, this is 11. So that's gonna be 110. This is 12. This is 120. 5 times 25 is 125. And 4 times 40 is 160. So still not getting there. So then I go 13 is 130. 14 is 140. 15 is 150. 6 times 25 would be 150. And then 7 times 25 would be 175. And then 5 times 40 would actually be 200. So then I got to come over here and I got to go 16 is 160, 17 is 170, 18 is 180, 19 is 190, and 20 is 200. And then 8 times 25 happens to also be 200. So there you go. So sometimes it can be a lot quicker, sometimes it can be a lot longer, but I found this one to be the easiest method than using the prime factorizations because I struggle with the factor tree. But 200 right here would be the answer. All right. So let's look at number 2, a different situation. All right, so number 2, we're going to add these fractions. We have 7/18 plus 1/18 plus 7/18. When we add fractions, how we talked about this in chapter 9, the denominators all have to be the same, and in this case, they are. So therefore, the denominator will still remain the same, and then all I have to do is the operation on top. So 7 plus 1 is 8, 8 plus 7 is 15, and so then I get 15 over 18, but we always want to reduce that. So I can reduce that by 3, so that would be 5 and 6. So if you divide both of them by 3, or you can type 15 over 18 into your calculator, and it will pop out 5, 6 as well as your simplified answer. All right, let's look at another one. So number 3, we want to add 1/6 plus 3/10 plus 7/12. Well, I have to have all these the same, so I need to find a least common denominator, or yeah, least common denominator using the same process. So I got 6, 10, 12. This is 1. So then 2, 6 is 12. Ooh, that's perfect. 2 times 10 is 20. Not quite perfect. 3 times 6 is 18. 4 times 6 is 24. 3 times 10 is 30. 5 times 6 is 30. 2 times 12 is 24. 3 times 12 is 36. 6. Oh, I don't know why I put 60 there. 6 times 6 is 36. And then 4 times 10 is 40. So now 7 times 6 is 42. And now 5 times 10 is 50. So then 8 times 6 is 48. 9 times 6 is going to be 54. 6 times 10 is 60. So then 10 times 6 is also 60. 4 times 12 would be 48. And then 5 times 12 happens to also be 60. So 60 is my winners. And what's really nice about this process is I also know what numbers I have to multiply by to get to that 60. And what that means is to get 6 to 60, I need to multiply by 10. So I need to multiply this one by 10. But if I do it to the denominator, I have to do it to the numerator. For the 10, I see I multiplied by 6. So I'm going to multiply this one by 6 and then the top by 6. On the 12, I see I had to multiply by 5. So then I multiply this one by 5 and then this one by 5. So there's a good process to this because it gives us a lot of information. So then 10 times 1 would be 10. 6 times 10 is 60. 3 times 6 is 18. And 6 times 10 is 60. 7 times 5 is 35. 12 times 5 is 60. So now I have the same problem that I have on number 2. The denominators are all the same. So 60 is going to stay 60, and I can just work the top. 10 plus 18 is 28, and then 28 plus 35. So 28 plus 35 gives us 63. And then we will try to simplify. So I can actually divide that by 3. I think it's the largest number I can think of. And it would give us 21 over 20. There you go. So that's the beginning of this process. So let's look at more of an algebra approach. We're going to still find the least common multiple, but this time we're going to be given 5x plus 15 and x squared minus 9. So these are our two. So here's the best approach with polynomials. Factor it out. So I see the GCF here is 5, and I would divide both of them by 5. So I get x plus 3. Over here, this right here, I'm trying to multiply to a negative 9, add to 0. So that tells me both numbers have to be the same. So it's 3 and negative 3. So I'd give you x plus 3 and x minus 3. So what we have to do is you have to look at these and make these both the same. So they both have an x plus 3, but this one's missing an x minus 3. So I'm going to multiply it by x minus 3 over here. And then this guy is then missing a 5. Now I have the least common multiple because now both of them are exactly the same. So you only have to write it down once, but one of those will be your answer because they're both the same. But that's the kind of the process. You factor it, figure out what is the other thing missing, and then add it to it or multiply it to it, really. All right. So let's look at another one. We're going to look for, again, a least common multiple of this situation. So we have 4y squared plus 4y plus 1. We also have 4y squared plus 2y. And then we also have 8y minus 4. So we look at this first one. There is no GCF, so I need to do a t-chart. So my t-chart here, I need to multiply to my a times my c, which in this case is 4. I need to add to my b, which is 4. So two numbers that multiply to 4 and add to 4 happen to be 2 and 2. So this becomes y plus 2, y plus 2. But then I have to divide by that a, simplify, so that becomes 1/2. The denominator moves to the front, so this becomes 2y plus 1 and 2y plus 1. Then we move on to the other one. I see that they have a GCF of 2y, so I'm going to divide both of them by 2y. 4 divided by 2 is 2, y squared divided by y is y. This right here would just give me 1. Then I come over here and I see again a GCF is 4. So I'm going to divide both of them by 4. So 8y divided by 4 is 2y minus 1. All right, so then what we do is we have to figure out what is missing. So I have a 2y plus 1. There's that. I have a 2y plus 1. There's that. But then this one is missing a 2y plus 1. I have a second 2y plus 1. This one's missing a second 2y plus 1. And so is this one. This one has a 2y, and this one's missing a 2y, and so is this one. This one has a 4. This one's missing a 4. And this one has a 2y minus 1, which all of these are missing a 2y minus 1. Therefore, any one of those now would have the same answer, and I don't know if they want you to simplify that. So let me see. They do. They kind of want you to clean it up just a little bit. Oh, wait, this one had a 4. I added another 4 here. This one had a 4. So look, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this also has the 2 minus 1. Sorry. And then 1, 2, 3, 4, 5. All right, so now they're all the same. I kept on adding as I went on. All right, so we just kind of clean them up. It doesn't matter which one you look at because they're all going to be the exact same. But 4 times 2y see, this one had a 4. I see what they did. So I'm going to take this 4 back away, and we need to look at this 4 is actually a 2 times 2. So they went a little bit further with this. So since they had a 2 already on all of them, it was just missing a second 2. So these two would just get a second 2. So that would give that 4 to it, which then would mean that this is only needing a y. Because it actually had a 2, it just missed the y. All right, very sneaky there. All right, so in that situation, I then get 4y, and then I have 2 of these, so this just becomes 2y plus 1 squared and 2y minus 1. There you go. Again, I found this to be the best process because I can kind of look and I can see, and I was able to adjust because I was like, all right, this was a 4. This actually ended up being 16, and I was like, whoa, 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 whoa. So I had to come back and go, all right, there it is right there. That was broken down by 2s instead of by 4s. All right. So let's do a couple more. Let's look at number 6. So these type of questions are going to ask you what's the missing numerator that would make it equal. So you are given negative 2x over 10x minus 5 equals 30x minus 15 on bottom, and we don't know what's going to be on top. Well, this is what you have to determine. What do I need to multiply 10x minus 5 to make it 30x minus 15? And start off with just one term. What do I need to multiply 10 to give me 30? If you say 3, then just check. Does 3 times negative 5 give you negative 15? And it does. So I can multiply this by 3. But if I do it on the bottom, I have to do it to the top. Now I know that 3 gives me this, So the answer I'm looking for is whatever this result is. So negative 2 times 3, or negative 2x times 3 gives me negative 6x. All right. And so that's all you have to do on that process to make them equal. All right, let's look at one more like this and we should be good. So I have 9x over x squared minus 1 equals x times x plus 1 times x minus 1 times x plus 3. And I'm trying to figure out what I need to multiply by. So first, let's factor x squared minus 1. Hopefully at this point you see it's x plus 1, x minus 1. But if you need to do the tree or the t-chart, multiply to negative 1, add to 0. So that's 1 and negative 1. All right, I see that it already has that, so I'm missing an x and an x plus 3. So therefore, I need to multiply this by x and x plus 3. But if I do it to the bottom, I have to also do it to the top. And I'm curious on your homework, did not make you full it out? They just make you clean up just a little bit. So 9x times x would be 9x squared, but then you can keep the x plus 3. You don't have to worry about folding it out. But that is what your homework will be looking for. All right. Other than that, that's all I have in this video. So I'll see you in the next one. Bye for now.